Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about Vsepr theory and shape of molecules. So this will be highly beneficial for BSc Chemistry students under CBCS syllabus. I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus for Core 1 paper Unit 4 Chemical Bonding. So today we are going to discuss BSEPR theory and shape of molecules like methane, water, ammonia, PCl3, PCl5, SF6 and ClF3. So let's discuss what is BSEPR theory. So the full form is valence shell electron pair repulsion theory, and this theory was given by Gillespie and Nylom. According to Vsepr theory, the geometry of the molecule depends upon the number of bonding and non-bonding electron pairs, that is lone pairs, in the central atom, which arrange themselves in such a way that there is minimum repulsion between the lone pair and bond pair, and the molecule has a minimum energy and attains maximum stability. Since there can be only one orientation of orbitals corresponding to minimum energy, so the molecule has a definite shape. So rules proposed by Gillespie to explain the shape of some covalent molecules. So rule number 1. So if the central atom of a molecule is surrounded by only bonding pair of electrons or bond pairs, so the geometry of the molecule is regular. So if we have two bond pairs, so the shape will be linear, and example is beryllium chloride. And bond pairs 3 means a trigonal planar, BCl3. Similarly, 4 bond pairs, so regular tetrahedron the structure, and example is SnCl4. Similarly, bond pair 5, so trigonal bipyramid and structure is PCl5. And bond pair number 6 is regular octahedron, or example is SF6. Then rule number 2, when the central atom in a molecule is surrounded by both bond pairs and lone pairs, the molecule do not have a regular shape. So the repulsion has following order: lone pair repulsion greater than lone pair greater than bond pair. So more the number of lone pairs on a central atom, the greater is the contraction caused in the angle between the bond pairs. So molecule number of lone pairs, methane has 0 and ammonia has 1 and water has 2 lone pair. So bond angle reduces from 109.28 to 107.5, and finally in water we have 105.5. So contraction of bond angle, so in case of ammonia by 2 degree and in case of water by 4 degree. So the bond angle BAB decreases with the increase in electronegativity of atom B in AB molecule, where A is the central atom, or we can call it AB2 molecule. So Pi3 102, PBr3 101.5 and PCl3 100 degrees 100 degree. So with increase in electronegativity of atom B, the average position of bonding electron pair moves further from the central atom A, and the repulsion with A decreases, and hence the decrease in repulsion decreases the bond angle. Then rule number 4, the bond angles involving multiple bonds are generally larger than those involving only single bonds. So however, multiple bonds do not affect the geometry of a molecule. Then rule number 5, the repulsion between electron pairs in the filled cells are larger than the repulsion between electron pairs in incompletely filled cells. Water 105.5, H2S 92.2 degree. Next is effect of lone pair. So let's talk about methane. So we have 4 bonding pair of electrons in valence shell of a carbon atom, central atom. So the structure is regular tetrahedron, bond angle is 109.28 minute. Similarly, in case of ammonia, 3 bond pair and 1 lone pair. So 4 electron pair means the structure would be tetrahedral. So due to lone pair, the bond angle is reduced from 109.28 minute to 107.48. In case of water, we have 2 bond pairs and 2 lone pairs. So 4 electron pairs means tetrahedral structure. So due to lone pair, the bond angle is also reduced from 10928 to 104.27. The next is the effect of electronegativity. So let's talk about NF3 and NH3 molecule. So which has 3 bond pair and 1 lone pair in the tetrahedron structure. So the high electronegativity of fluorine atom pulls the bonding electrons further away from nitrogen atom than in ammonia. So thus the repulsion between bond pairs is less in NF3 than in NH3. So hence the lone pair in NF3 causes greater distortion in bond angle value and gives a FNF bond angle of 102.30 compared to 107.48 in ammonia. And the same effect is found in case of water and F2O. The next is isoelectronic principle. So isoelectronic molecules or ions have the same structure. This may be extended to the species with the same number of valence electrons, just like methane BF4 minus, NH4 plus. So all are tetrahedral. Similarly, carbonate CO3 2 minus, nitrate NO3 minus, and SO3 all have a planar triangle. Similarly, carbon dioxide N3 minus and NO2 plus all are linear. So let's discuss the limitation of Vsepr theory. So Vsepr theory cannot explain the shape of very polar bonds like Li2O. So should have the same structure just as water, but it is linear. Vsepr theory is unable to explain the shape of molecules having extensive delocalized pi electron systems. Vsepr theory cannot explain the shape of certain molecule which have an inert pair of electrons. And Vsepr theory is not able to predict the shape of certain transition metal complexes. So let's discuss the shape of methane molecule based upon Vsepr theory. So here in methane the central atom is carbon. So according to Vsepr theory we have to find out the number of electron pairs in outer shell or valence shell of central atom. So carbon atomic number 6, electronic configuration of carbon is 1s2 2s2 2p2. So this is the valence shell electronic configuration 2s2 2p2. So carbon in excited state the electronic configuration will be 1s2 2s1 2p3. So one of the 2s electron will be excited to the 2p orbital. So we have here 4 unpaired electrons, valence electrons. So these 4 unpaired electrons will form bonds with 1s orbital of a 4 hydrogen atom forming methane molecule. So this methane molecule contains 4 electron pairs, that is 4 bond pairs and lone pair 0. So the structure would be tetrahedral and bond angle is 109.28 minute. So this is the structure of methane. So let's talk about the shape of water. So the central atom here oxygen. So according to valence shell electron pair repulsion theory, we have to find out the number of electron pairs, bond pairs and lone pairs in the outer shell of central atom. So oxygen atomic number 8. So electronic configuration is 1s2, 2s2, 2p4. So here the valence shell has 2 lone pairs and 2 unpaired electron. So these 2 unpaired electron can form bond with 2 hydrogen atom of 1s orbit having 1s orbital forming water molecule. So water molecule contain 4 electron pairs, 2 bond pairs and 2 lone pairs. So the structure would be tetrahedral. But according to Vsepr theory, lone pair repulsion greater than lone pair bond pair repulsion and bond pair repulsion. So due to minimize this repulsion, the bond angle reduces to 104.5 and the structure is V-shape. So now let's discuss the shape of ammonia molecule. So the central atom here nitrogen. So according to Vsepr theory, we have to find out the number of electron pairs, bond pairs and lone pairs in the outer shell of central atom nitrogen. So nitrogen atomic number 7. So electronic configuration is 1s2, 2s2, 2p3. So valence shell contain 1 lone pair and 3 unpaired electrons. So these 3 unpaired electrons can form 3 bonds with 1s orbital of 3 hydrogens forming NH3 molecule. So ammonia molecule contains 4 electron pairs, so that is 1 lone pair and 3 bond pair. So the structure should be tetrahedral. So according to Vsepr theory, to minimize this repulsion, so bond angle reduces to 107.48 and the structure of ammonia is pyramidal. So let's discuss the structure of PCl3. So here in PCl3 the central atom is phosphorus P. So according to Vsepr theory, we have to find out the number of electron pairs, lone pairs and bond pairs in outer shell of central atom. So phosphorus atomic number 15. So electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. So that means here one lone pair of electron and 3 unpaired electrons in the valence shell. So these 3 unpaired electrons can form with a bond with 3 chlorine atoms. So forming PCl3 molecule. So PCl3 molecule has 1 lone pair and 3 bond pairs. So total 4 electron pairs. So the structure would be tetrahedral. So to minimize the repulsion between lone pair and bond pair according to Vsepr theory, here the bond angle reduces to 103 and again PCl3 has a pyramidal structure. So let's discuss the shape of PCl5. So phosphorus pentachloride. Central atom is phosphorus. So according to Vsepr theory, we have to find out the number of lone pair and bond pair. So that is electron pairs around the outer shell of central atom. Phosphorus atomic number 15 and electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. So we have 5 valence electrons. So all these 5 valence electrons can form bond with 5 Cl atoms, so forming PCl5 molecule. So that means PCl5 contain 5 electron pairs, 5 bond pairs and no lone pairs. So the structure would be trigonal bipyramid. So here the bond angle is 120 and 90. So let's discuss the shape of SF6 molecule, sulfur hexafluoride. So here central atom is sulfur, atomic number is 16. So electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4. So here we have 6 valence electrons. So these 6 valence electrons can form covalent bonds with 6 fluorine atoms forming SF6 molecule. So SF6 contains 6 electron pairs, that means 6 bond pairs and 0 lone pair. So the structure of a SF6 is octahedral and bond angle is 90 degree. So now let's discuss the shape of a ClF3 molecule, chlorine trifluoride. So central atom here is chlorine. Chlorine atomic number 17. So electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So we have 7 valence electrons. So out of 7 valence electrons, so 3 electrons will take part to form 3 ClF bonds and remaining 4 electron will remain as 2 lone pairs. So forming ClF3 molecule. So that means ClF3 molecule has 5 electron pairs. So 3 of them bond pair and 2 of them lone pairs. So the structure should be trigonal bipyramid and all these 3 fluorine atoms and 2 lone pairs are arranged in structure 1 and 2 and 3. So groups 90 degree to each other repel strongly while groups 120 degree apart repel less. So the correct structure is number 3 and ClF3 has T-shaped structure and bond angle is 87.6. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistryliveugpg.com. For class 11th and 12th students, this is the channel Foundation Chemistry AV. So this is a simple step towards e-learning making life better. Thank you all for learning.